And at this point, I would encourage you to pause the video, get to this point so that you can read the story problems along with me. So here we go. Question number 1. Phyllis made a rectangular blanket that measures 5 feet by 6 feet. She wants to use exactly 12 square feet of fabric to create a border around the blanket. What equation can she use to find the required width of the border X? Alright, so oftentimes when I read a story problem, I'm a little confused. I'm not really sure what they want. So the best starting point for me personally is to draw a picture. So we're going to go ahead and draw a picture of a blanket. So we're going to just draw a rectangle, and we are going to label that as 5 feet on this side and 6 feet on this side. But remember, our focus here is that we're going to create a border around the blanket. So let's go ahead and draw another rectangle that goes around the outside perimeter here of that. That was a terrible rectangle, by the way. And I'm going to go ahead and shade that in to show you that this is the focus. We're only focused on the rectangular border here. Now remember, the story problem says that she's going to make the width of the border X. Well, what that means is that on this side, this right here is going to be X, and over here on this side, this is going to be X. So remember, the blanket was 6 feet, but we're going to extend it by X over here and by X over here. So that means that this new length here is really 6 plus 2 X's. Now the same thing is going to happen along this side. Remember, this is also going to be X, and going up from here is going to be X. So where the blanket was 5 feet, now with the border it's going to be 5 plus another X and another X, which means that it's really going to be 5 plus 2X. Now, we do not want to worry about the blanket itself. We're just worrying about the border. So the blanket itself is a 6 by 5. If we deal with the area of this blanket, we're going to use length times width, or in other words, 6 times 5, to find out that the blanket is 30 square feet. So we want to make sure that we don't use the 30 square feet, that we take it away from the initial information. So we're going to set up our equation by taking the length of the blanket with a border times the width of the blanket with the border. We want to take out the 30 square feet because, again, we're not worried about the blanket. And then what we want to do is set that equal to how much fabric she's going to use. So now go back and reread the story problem. In the second sentence, it says she wants to use exactly 12 square feet of fabric to create a border around the blanket. So we want to equal that to the 12 square feet. Now at this point, we need to simplify this equation. So notice that we have a binomial times another binomial. And when we're taking a binomial times a binomial, we want to use the FOIL method. So we're going to multiply the first terms, then we're going to multiply the outside terms, then we're going to multiply the inside terms, and finally the last terms. And 2x times 2x is 4x squared. We're going to drop down the minus 30 and the equals 12. Now at this point, the equation is still not simplified. I mean, we got rid of the parentheses, but we want to combine some like terms together. I use something called the bridge method because I want to make sure that I'm staying with one side. So on the left side of the bridge always goes down the equal sign. We're going to take a look at what can we combine. Well, 4x squared is the only thing that says x squared, so we're just going to go ahead and drop that down because it cannot be combined with anything else. The 12x and the 10x can be combined to make 22x. And then notice our constants here are 30 minus 30. Well, 30 minus 30 is 0, so we don't even need to worry about writing anything down here for that. I'm going to drop down the equals 12, and then as you should have learned from section 9.1, you need to write it as a quadratic equation, which means that it has to equal 0 on the right-hand side. Well, the only way to make that equal 0 is by moving the 12 over to this side by doing the opposite operation. Since 12 is positive, we want to make it a negative, so we're going to rewrite this as 4x squared plus 22x minus 12, and now it's going to equal 0. So if you guys will go back to question number 1, I actually just walked you right through how to do question number 1, and there you'll see the answer. It is the fourth response down, 4x squared plus 22x minus 12 equals 0. All right, now for question number 2, it is now going to ask you to solve this problem. They want to know how wide should the border of the blanket be. In other words, they want to know what is x. So going back to this equation, you need to solve it. Now, from 9.1, you should have learned that there are two different ways that you can solve a quadratic equation. The first way is the factor method. The factor method can only be used if x squared is by itself and does not have a coefficient. So since x squared has a coefficient, we have to go to plan B, and plan B is to use the quadratic formula. Now the quadratic formula, again, was taught to you in section 9.1, and that is negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, I'm actually not going to walk you through this part because this is from 9.1. If you are struggling with a quadratic formula, then I suggest that you go back to the notes that I emailed or go back to 9.1 and review that. And if you're still struggling with that, please contact me. But I'm going to leave it at that. To answer question number 2, you do need to take these, the a, the b, and the c values, plug them in so that you can solve question number 2. Okay, now let's go ahead and take a look at question number 3 here. Question number 3 is now looking at making a flag. It's the same idea. It has a border around it. It's going to be just like our blanket problem. So I'm not going to go through question 3 just because you want to set it up the same exact way we just did question number 1. Make a drawing, work out the length and the width, set it as an equation, and then solve that using one of the ways of solving a quadratic formula. Okay, question number 5. A graphing total of snowfall over time would be a quadratic function. Okay, so for something to be a quadratic function, that means that when you graph it, it's actually going to have that U-shaped look to it. Versus a linear function, linear means line. Well, I want you to think about graphing the total snowfall over time. Is that going to go up and then down? Or will the total amount of snowfall just continue to increase? Well, if you think about it, snowfall is just going to increase over time. So that's going to be our linear function. Therefore, it can't be a U-shape, which means that answer is going to be false. All right. So now what we're going to do is we're going to take a look at question number 6. I will tell you that when I look at question number 6, my first reaction is, yikes, there's too many letters, there's too many numbers. And my first reaction is I want to run away. But don't run away because this problem isn't as bad as it looks because their numbers are huge, but the actual thing that we're going to use here to solve it is not too bad. So go ahead and read that to yourself for a moment. Alrighty, now that you've read that, you will see that the quantity of the toys is negative 5s plus 1300. And we know that from the notes that you should have taken from 9.2 that the profit formula is P equals total revenue minus production cost. And they went ahead and gave you what that would be for that particular problem. Now, what we need to do is figure out what is that going to be for this specific problem. So, let me get a new piece of paper here. What we're going to do is we are going to take our profit formula, which they gave us. Now remember that they already gave us the equation that shows the relationship between the quantity sold and the selling price. Well, that is Q equals negative 5s plus 1300. Okay, so none of that we had to come up with on our own. That was just provided to us. So since we know that Q is equal to negative 5s plus 1300, what we want to do is we want to plug that in for Q here, and we want to plug it in for Q here. So the numbers are going to kind of get big. This is where having a calculator is going to be super duper handy. Alrighty, so let's go ahead and plug this in. P equals, don't forget the S is attached to the Q by multiplication, so we're going to put S, and then to multiply it, we're going to write parentheses, and we're just going to plug in what Q is here into the parentheses. Okay, then we're going to bring down our minus and our 80, and then 80 is being multiplied to Q again, so we're going to set up parentheses and go ahead and plug in what Q is. from here again. Alrighty, now our goal is to now simplify this, and so we are going to have to multiply this monomial to this binomial, and this is something that you should have learned from some of the previous units. S times negative 5s is negative 5s squared, and then we're just going to multiply s to that, so that'll be plus 1300s. Now don't forget that 80 has a minus sign next to it, so we want to consider this a negative. So when we're multiplying it, we want to take negative 80 times negative 5s. So a negative times a negative is positive 400s. And then again, we're going to take negative 80 times positive 1300. That's going to be negative, and that will be 104,000. So it'll be 104,000. And I forgot to bring down the p equals at the beginning there. Now we still need to simplify it, so taking a look at what's on the right side of the equal sign, the only thing that can be simplified is by combining the 1300 to the 400s. So that's going to give us p equals negative 5s squared plus 1700s, bring down the minus 104,000, and that is the formula that we're going to use for the profit. So if you guys go back to question number 6, the question wants to know, does p equal negative 5s squared plus 1700s minus 104,000 equal the equation that we would use for this problem? And that matches up with what we got there. Therefore, the answer is true. Okay, so now for question number 7. Now what we need to do is figure out the maximum profit. And I'm really bothered by the fact that there is a misspelled word there, so please note that I do see that. But we're looking for maximum profit. Now, if you'll think about the notes that they talked about in 9.2 section, they talk about that graphing the profit would form a parabola. And the peak of the parabola here is the vertex. And that's the highest point that the graph will ever be. So if that's the highest point that the graph will be, then that is exactly where our maximum profit will be for selling the toy. And so what we need to do is go back to the notes again where we learned in 9.1 about vertex. To figure out the vertex of a parabola, we want to use the formula negative b over 2a. And so at this point, what we want to do is go ahead and identify our b and our a from our equation. So remember, a is the coefficient of the s squared, and b would be the coefficient of s, and c, which doesn't apply to this one, but c is always going to be the constant. All right, so our b value is 1700. So we're going to write the negative sign out to the left here, put our fraction bar, we're going to put 1700 on top, and then we're going to take 2 times a, and our a value is negative 5. All right, so we're going to now rewrite this as a negative sign, 1700 over negative 10, and the negatives are going to cancel each other out to make it a positive, so 1700 divided by 10 is 170. So that means that the maximum profit is going to be 170, or in other words, $170.